Hi everybody. We are starting our second to last unit today. And so this unit is all about something that we call special functions. We call them that just because we haven't dealt with these functions yet. And so we just call them special. But really what it is it's just an introduction to some different kinds of functions that you're going to see as you go throughout your math classes in high school. So the first thing I'm going to show you is a chart that I created, and it's called the parent function chart. It's kind of a strange name, but really what it means is this is what the basic function for each type would look like. Okay, so you can see I have type of function, equation of the parent function, and graph of the parent function. So the parent function of a linear function is just the line y equals x. Okay, it's almost like the most basic of the lines that you can have. So it has a y-intercept of 0 and a slope of 1, and so the graph looks like that. You might be wondering why we care about parent functions, and really the reason we care about them is because as soon as you start changing numbers within the function, it changes what the graph looks like. So for example, if I changed that equation to say y equals x plus 2, I would want you to know that the way that that function was changed was it was shifted up 2 places because now the y-intercept is 2 and the slope is still the same. Or if I said y equals 3x, I would know that it's different if it's different from the parent function because although it still goes through the origin, now the slope is 3, so it's more steep than the original parent function was. So it's kind of a way to compare the functions that you're given to what the parent function is. Okay, so the second half of this unit is all about changing the functions from their original version. Okay, so just in a quick snapshot, that's why we talk about these parent functions. Okay, so for the second kind here, this is a quadratic function. This is the second kind of function we learned this year. And so the parent function for that is y equals x squared. So you can see on the graph there, that's just a parabola whose vertex is the origin. And if I keep going down here, the next type of function we learned about is an exponential function. And you can see the parent function for that is y equals 2 to the x. Okay, so these last ones here, these are the new ones that we're going to be covering in this unit. So we have the absolute value function, we have the square root function, we have a cube root function, and we have a cubic function. So those are the 4 new parent functions that you're going to learn about in the first half of this unit. Okay, so let's jump right in. Today we're actually going to talk about the first, well, I guess it's not really the first 2 in here. It's the square root function and the cube root function. So that's what we're going to talk about for today. So I'm going to actually have you pause the video, and I want you to grab your graphing calculator, and I want you to put in this equation. Okay, so you're going to type in the square root of x. That's the parent function of a square root function. Okay, so pause me and then press play once you have that in. So what we're going to do is we're actually going to graph this to start. So once you have that pulled up on your graphing calculator, I want you to open up your table. So Control T. And let's graph some nice points. So we should see that our function starts at the origin, based on our table, 0, 0. There's a point at 1, 1. The next nice point, meaning whole numbers here, is 4, 2. And if you think about it, what you're doing is, because the function is the square root of x, I'm saying, okay, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. So the next nice one would be the square root of 9 is 3, and so on. So if you graph your perfect squares as your x coordinates, you'll always get a whole number for your y coordinates. And this function will just continue on kind of in that direction. So one thing that's kind of interesting to talk about is If you look on your table at any of the negative x values, you guys are going to see that there's an error message. And the reason why that's happening is because I can't take the square root of a negative number. Okay, so for example, if I try and take the square root of -4, that's an imaginary number, so that's not showing up on my graph. Okay, so this is one of those characteristics of this square root function that's really important to understand. Okay, so let's answer some of these questions now that we've looked at the graph and talked about it a little bit. So is it a function? Yes, it is. And we can say every input has exactly one output. We can say it passes the vertical line test. Whatever you would like to say for that is fine. I'm going to go with our classic, every input has exactly one output. Okay, so the domain for our function. So remember, domain is all of your possible x values that we can have. So just looking at your graph, you can see the furthest left that our graph will go is 0, and it includes 0 because there's actually a point there. So I'm going to start my domain with a bracket and 0. And then if I look for how far right my function goes, it just keeps going on to infinity. So 0 to infinity would be my domain. For range, remember we're talking about all the possible y values. Okay, so if you look at the graph, what's the lowest your graph can go? Again, that's 0. And the highest the graph will go, again, is infinity. Okay, x-intercepts. This means where does your graph cross the y-axis, or I'm sorry, the x-axis, x-intercept. And that is at one place, 0, 0, which actually happens to also be the y-intercept. So the y-intercept is the same. So the graph crosses the x and y-axis at the same point. Number 6, where is the graph decreasing? So remember, when we talk about increasing and decreasing, we read our line from left to right. So in this case, if I'm looking left to right, my graph is never decreasing. It's always increasing. So I'm going to say that it's increasing between 0 to infinity. Okay, remember we use the x values when we talk about increasing and decreasing. So when x is 0 until x is infinity, my graph is increasing. And we never include the numbers when we talk about increasing and decreasing because it's between those points that it's increasing. So where is it decreasing? We said never. Where is f of x negative? So this means where is y negative? Because remember, f of x is really y. So am I ever going to get a y coordinate on this graph that's negative? No, that's never going to happen. My square root is always going to be a positive there. So I'm going to say never. And so where is f of x positive or where is y positive? Basically anything that's plotted. So we would say between 0 and infinity. Now why am I not including the 0 there? Think about what the word positive means. So 0 is considered neither positive nor negative, and so we don't want to include it because that would imply that 0 is positive, and it's not. All right, where is f of x equal to 0? So this is saying where is y equal to 0? Well, if y is 0, it's because x is 0. And again, I can look right at my graph to get that, or I can look at my table and I would see that when y is 0, x is also 0. For number 11, find f of x when x is 7. So basically, I'm being asked to put 7 in for x and to say what y is. And so what you're really doing is you're finding the square root of 7. So my work for this would look like this. Find f of 7, which would be the square root of 7. So f of 7 is going to be, let's go to the nearest hundredth, 2.65. Since we know 7 is not a perfect square, we're going to have to round that decimal. Okay, for what x value or values is f of x equal to 4? So this is asking me what is y, what is x, sorry, I had to reread that. What is x if y is equal to 4? So what number would you have to put in to the square root to get an answer of 4? 16. The square root of 16 gives me 4. So x would have to equal 16. Okay, the maximum value of the graph. So this is just saying how high does my graph go? What is my end of my range, which we've already said is infinity. What is the minimum value of the graph? So the lowest that it goes, we said was 0. And this right here means as x approaches positive infinity. Okay, so as we go to the right on our graph, so x is going to infinity. What happens to f of x, or what happens to y? Well, if x is going to infinity, y is also headed towards infinity because at the same time on that graph, they're both increasing. So they would both be going to infinity. Okay, great job. So what we're going to do next is look at the cube root function. So it kind of follows our square root here. So again, pause the video. I want you to type this into your calculator, the cube root of x. If you're not sure how to type that into your calculator, you're going to want to use the key that is next to x squared. So I call that the caret key. So you would press Control caret key, and then in the little box that shows up before the square root, you'll put in a 3 for cube root, and then you'll put x underneath the cube root sign. Okay, so get that plotted, pull up your table, and let's talk about some points that we see here. So with this one, there aren't a whole lot of points that we can graph here. Remember what we're doing is we're taking the cube root of a number and we're graphing what it is. So the cube root is what times itself 3 times gives you that number. So if I'm asking you for the cube root of 0, the answer would be 0 because 0 times itself 3 times is 0. If I'm asking you what the cube root of 1 is, well, 1 times itself 3 times gives me 1. Another one we will see on the table here is the cube root of 8. So what times itself 3 times? Oop, there we go. It would be 2. 2 times 2 times 2 is 8. So that would be the last point going that way that we can plot. Now what's interesting about cube roots is you can actually take the cube root of a negative number. Okay, so let's talk about that for a second. If I were to multiply negative 1 times itself 3 times, negative 1 times negative 1 is positive 1, and positive 1 times negative 1 is negative 1. And so the cube root of negative 1 is actually negative 1. So this is a case where you could get a negative answer. Okay, so similarly, if I take the cube root of negative 8, my answer would be negative 2, because negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. Okay, so this is definitely an interesting looking function here. I'm going to kind of connect, looks like that. So kind of a low but squiggly line in a way. Okay, so is this a function? Yes. You can say, I'll change up my explanation here. It passes the vertical line test. So maybe if you wrote that for the first one, maybe for this one you'll want to write that every input has exactly one output. Okay, our domain. So the furthest left and right this graph goes is all the way from negative infinity to positive infinity. The range will be the same. The lowest it's going to go is negative infinity. That arrow to the left is going to keep going down. And the highest it goes is going to go to positive infinity because the arrow to the right is going to continue to go up. All right, any x-intercepts. So where does the graph cross the x-axis? at 0, 0. Y-intercept is actually the same. Where is the graph increasing? Okay, so this one's a little tricky. Remember, we're reading left to right. So starting at our left side, probably better to look at your graph on the calculator because I'm looking at mine and it's not too perfect. So if I'm looking left to right and I'm looking at how it's changing, you should see that as you're going left to right, your graph is always increasing. It's always going up a little by little. And so where is it increasing? It's increasing everywhere, from negative infinity to positive infinity, which means it's never decreasing. Okay, where is f of x negative? So remember, this means where is y negative? So if I look at my graph, I need to say, okay, between what x values do I get a negative y value? So that means that basically starting all the way at negative infinity and stopping at 0, between those x values, that's when I'm going to have y values that are negative. So it's kind of like that first half of the graph, all of your y values will be negative. So we want to say all the way from negative infinity to 0 is where we're going to have negative y values. And then where is f of x positive? So when are we going to have positive y values? Well, that's the second half of the graph. That's on the right side. Anything above 0 is going to give me a positive y value when I plug in a positive x. So I'm going to say from 0 to infinity. Okay, number 10, where is f of x equal to 0? So basically, what is x if y is 0? X is 0. There's only one point on that graph where y is 0, and x is also 0 at this point. Number 11, find f of x when x equals 64. So basically, they're saying, what is y when x is 64? So I'm going to plug in 64 for x into my function here. Now you could look at the table and you could go all the way down until x is 64 and you could figure this out. Or you can always just open a calculator page and say, okay, what's the cube root of 64? So remember to use that control caret to do that. And if you were to do this correctly, you should be getting that the cube root is 4. And again, that's because 4 times 4 is 16, and 16 times 4 is 64. Okay, for what x values is f of x equal to 2? So this is saying, what do I have to find the cube root of to get an answer of 2? And we can actually see that right on our table, or on our graph up here. So again, what is x when y is 2? Well, when y is 2 on our graph, we can see x was 8. And there we go. All right, the maximum value of the graph. So how high is this graph going to get eventually? Eventually it's going to get to infinity. And then the minimum value, how low is this graph going to get eventually? Eventually going to get to negative infinity. And the last part here, okay, as x goes to positive infinity, what happens to f of x, or what happens to y? It also goes to infinity. As x goes to negative infinity, so as I go left on my graph, what happens to y? It also goes to negative infinity. Okay, all right, so that is kind of this little snapshot of some characteristics of each of those functions. So let's look at some questions that you might see based on those two types of functions. So number 1 says, what is the domain of this function? Now, one thing you're going to look at is you're going to say, okay, this is a square root function, right? Just based on the shape of it, it's a square root function. And the other thing I want you to realize is it's not the parent function. It was shifted in some way. So it looks a little different than how we originally graphed the square root function. Okay, so that'll come into play later in the unit. But you don't really need to know much about it because you can still find the domain just by looking at the graph. So I can see that from left to right, my smallest number for x is -4, and it includes it because there's actually a point there. And the highest number that x will be is infinity. So it looks like choice 3 is the proper domain for this one. Okay, number 2 right next to it. Here they're giving you this function. So we can see, again, it's a square root function, and we can see that not only on the graph, but in the equation they give us. Obviously much more complicated than the parent function for a square root, but that's okay. We're going to start by saying the domain. So the furthest left that function goes is at -1, and there's actually a point there, so we're going to include that. So -1 is the start of our domain. And how far right does our graph go? It goes to infinity. Okay, the range, so remember range is your y-axis. How low does that equation, that function go? The lowest it goes is -2, and there's a point there, so I include it. The highest it goes is infinity, so there's our range. Okay, where is our function positive? So when it says positive interval, that's what that means. When is f of x positive, or when is y positive? So you can see that y starts to be positive when x is 0. Okay, so this point right here is kind of that starting point for where y starts to become positive. So I'm going to say starting at x is 0 all the way to x being infinity. That's when my y coordinates are all positive. The negative interval would be kind of the opposite side of that function. So when x is -1, I have a negative y. So when x is -1, you see how y is -2? So that's the start of my negative interval. And I am allowed to include that because -2 is a negative number. Okay, so the only reason we weren't including 0 in the positive interval is because 0 is not positive. Okay, but because I actually have a negative number here that I get, I can include it. And then it goes all the way until 0. And again, we can't include 0 as being negative, so we leave it as a parenthesis. Okay, so just to kind of recap that really quick. A positive interval means between what x is, do I get a positive y coordinate? So when x is 0 to infinity, I get a positive y coordinate. Where it's negative is what x values give me a negative y coordinate. So when x is between -1 and 0, I get a negative y coordinate. So that's kind of how you think about those positive and negative intervals. Now, when it asks you to describe the left end behavior, what that means is like looking at the left, so this point right here, what's happening there? So left end behavior is like what's happening at that end. So we would just say as x approaches -1, y approaches -2. So in the other examples we were saying as x approaches infinity, y approaches infinity. So if this was asking for the right end behavior, that's what we would have said. But the left end behavior, it stops. It doesn't keep going. And so we don't have any infinities to put in there. Okay, number 3. Here's a function, it's a cube root function, on which interval is g of x decreasing. All right, so reading left to right, hopefully you can see that if you were to trace that with your finger, you're constantly decreasing. You're never increasing here. So the interval it's decreasing is basically all real numbers, -infinity to infinity. Number 4, function f of x shown below is a transformation of the square root function. What is the domain of f of x? Okay, so what that means is we're looking at a square root function. It's not the parent function. That's why it says it's a transformation of it. So it's just changed in some way. And they want to know the domain. So again, domain is left to right. The furthest left this function goes, we can see it's -infinity. It keeps going on in that direction. So -infinity, and the furthest right it goes is 3. And it includes it because there's a point there. The range, so the lowest our function goes on the y-axis is 1. And again, there's a point there, so I'm going to include it. And the highest our function goes is infinity. Okay, part C, which of the following is true? It's increasing and positive on the interval negative infinity to 3. Okay, so from negative infinity to 3, so basically looking at the whole graph, is it true that it's increasing and positive? No, it's actually decreasing and positive. So that choice is out. Choice 2, decreasing and positive. So that's exactly what I just said. So we know that's the right one. But let's read the other two just to make sure we know why those are not true. Increasing and negative. Okay, so both things are wrong there. It's not increasing and it's not negative. And then decreasing and negative, again, it's decreasing, but it's not negative. Okay, one more here. Function h of x shown below is a transformation of the cube root function. Okay, so again, it's a cube root function. Looks a little different from the parent function because it's been transformed in some way. But we can go through and we can say what the domain is. So furthest left and furthest right, well, we have those arrows that show it's going to keep going. And so this thing's going to go from negative infinity to positive infinity. What is the x-intercept? We can see that right here. It's where does the graph cross the x-axis? That's at 2, 0. On which interval is the function positive? So again, between what x values do we get positive y values? So we are going to say, okay, starting at when x is 2, I would have a y value of 0. Well, 0 technically isn't positive, so when I go to write my 2, I need to use parentheses. And then I'm going to say, basically, anything beyond that, right? 2 to infinity, I'm going to have all positive y values. All right, guys, great job. I know that's tricky, but we will not be doing much more than that with our square root and cube root functions. So as long as you know your basic characteristics, you will be good, and we will practice this more. So good job.